Okay, welcome back. It's August 18th. We are doing some more word problems in the quant. And again, just administratively speaking, this is where you see multiple choice answers and copyright notice. All of these things are from the free GMAT prep software and our copyright GMAC. Okay, cool. Let's do one. Let's do one. How about this one? Don't forget where you find multiple choice answers. There they are. Okay. Okay, we should be probably wrapping this one up. Remember what time management is in the quant section, in the verbal section too, but time management is really just, are you getting anywhere honestly? And if you are not, then you should just quit. So that's really all that time management is. Don't forget that. I mean, time management has nothing to do with minutes or seconds or with, and definitely nothing to do with being fast. Those are all big misconceptions. Like you don't have to be fast. In fact, trying to be fast will definitely work against you on this kind of thing. And nothing to do with minutes and seconds either. But there are still a lot of non-responses to this. So I'll wait another 30 or 40 seconds for you guys to pick something. And then we'll talk about it. All right, let's talk about the problem, guys. All right, there's still a few non-responders. Really, they're all the same part of the alphabet. Chris, B, Chitana, Fiorella, Gabriella, Miranda. They're all in the C to G range. But we got to move on here. Okay, let's discuss. Okay. Gabriella just clicked the away button. Let's talk about this problem. So, okay, I mean, one thing about this exam that is very consistent is the fact that problems that seem complicated usually tend to be, in actuality, usually tend to be less complicated. Like, if it seems like there's a bunch of stuff going on with some problem, then almost always what that indicates is that there's really less going on with that problem, and that the secret to it is something that is actually simpler. So you should, I mean, almost always, in fact. I mean, the problems that seem on the surface to be sort of uncomplicated are very often the ones that have multiple levels of stuff happening and where you have to think about it a little bit more. So just keep this in mind. If you encounter a problem that is seemingly simple, then there might be more to it. And if you have a seemingly complex problem, then almost always there's going to be some sort of simple key. And so you should look for that. And the word simple doesn't necessarily mean easy. It just means simple. It just means that there's going to be some sort of key to it that doesn't have a ton of complexity. I mean, as for whether you can think of that, that's going to be a matter of whether you know how to make certain associations or not. So, okay. But let's see what's going on here. So here they're defining what an average daily balance is. I mean, this isn't really any information about anything that you didn't already know up to here. Like, this is just, okay, the average daily balance is the average of the daily balances. Well, that's great. You can probably guess that. So really the actual problem kind of starts after that, right? But at the beginning of a certain 30-day cycle, her account has a balance of $600. And then she made one payment of $300 during the cycle. And then nothing else happened during that entire cycle. Okay, so in other words, there was some sort of, there's a $600 balance, and then she made a payment, and then for the rest of the time, there's $300. So you have a certain number of days up to here when the balance is $600. Just during this time. And then for these days, the balance is $300 for these remaining days. Aha. So it's a 30-day cycle, right? I mean, basically it's n number of days. Yeah, if she makes the payment on day n, then there are n number of days where there's a balance of $600. And then there are 30 minus n days where there's a balance of $300. So her average daily balance is going to be a weighted average of those things. Can someone tell me a story about that? Any comments on that in the chat box? Nobody's chatting anything about that. I mean, basically what we want is we want the average of n days at $600 and 30 minus n days at $300. And it's a data sufficiency problem. So what do we actually have to find here? Aha. Like, all we really have to find is n, or what day did she pay that? Because remember, like, data sufficiency problems are, you don't actually have to calculate stuff. You just have to know whether stuff can be calculated or not. So, and in order to do that, all you'd have to do is to have the value of n, right? I mean, you know, because basically when you review this problem, this sort of thing, like when you go back and review it after n is 20? What do you mean n is 20? I mean, well, you could, depending on how you define what n means, I mean, you could, yeah, it could be 21 or 20 or whatever, but the point is it doesn't matter as long as we have a value of stuff, right? If you don't even have to go in there and check the definition too carefully. I mean, if the payment credits that day, and then yeah, it would be 20 days of 600. And if the payment credit's not until the next day, then it would be 21 days of 600. But it would be something, right? So the deal is that if you have, like, this is something that you can calculate. This is something you can find if you have the value of n. It's a formula. I mean, when you review the problem, you should make sure that you know how to actually write the formula for this average. But when you're doing the work here, the point is there's no reason to bother doing it. Like, there's no reason to actually write that formula. Like, you should just be okay. So just, and I mean, make sure that you maintain that distinction in your head. Like, make sure that you have two different thought processes here. Like, when you review the problem, you should actually write the formula for this weighted average in terms of n. Whereas when you're actually doing the problem, you know, under simulation conditions, you should do, I mean, definitely do not bother to actually write the formula. Just realize that you can. So yeah, it's something to find if you have the value of n. It's something you can find, sure. So, any questions about this? Smiley face if this all makes sense. If you have the value of n, this is a thing. Okay. So, statement 1 gives you n. I mean, this will give you, as Lynn points out, this, whether n is 20 or 21 is another issue that if you were actually going to do the math here, you would have to grapple with this issue of exact values of n. Like, is it 20 or is it 21? Or, I mean, there have been multiple choice questions where you actually have to deal with that stuff. And you have to look at definitions and be careful about it. You know, like, do we credit things at the end of the day, beginning of the day, start of the month, end of the month? I mean, you might actually have to look out for that sort of thing. So in data sufficiency, you don't. And this is another sort of thing that you want to be very, you know, you want to be judicious about using time and mental resources on that sort of thing. Like, you know, data sufficiency problem, there's no point in thinking about that. If it was multiple choice, that would be a good thing to think about. If it's data sufficiency, it isn't. So, yeah. So statement one gives you n, so that's sufficient. Now, statement 2, the average daily balance through the 25th day of the billing cycle. Well, see, okay. I mean, what's the deal there? So, I mean, again, if people are still talking in the chat about whether n is 20 or 21 or whatever, guys, it doesn't matter, right? As long as you have it, it makes no difference. I mean, like, this is exactly the kind of thing that it doesn't matter on a sufficiency problem. I mean, as long as we are on board with the notion that you have n, then we are good. That's the point. And make sure that you don't have the wrong mentality here. Statement 2. We're going to do that in a second. I mean, first let's talk about the problem the rest of the way through. But statement 2 is kind of the same sort of deal, except now you'd be looking at this for 25 days. So In other words, statement 2 would just look sort of like this. So statement 2 is the same kind of situation here, except you're changing this to 25. And then you're saying that this weighted average is 540. What does that mean? What does that mean that you can do? This does mean that the payment was made before the 25th. That's true. I mean, you could set up linear equations if you didn't make the realization that you could make, then you could set up linear equations again. But I mean, think about the realization that we made up here about this weighted average. And this is just going to be a formula again, right? I mean, same sort of deal here. And this is going to be, again, this is going to be a formula that you can write in terms of n. So, because also this is going to be, if you think about it, if you don't feel like writing formulas, you can just kind of use intuition if you want. I mean, this is going to be some sort of formula in terms of n that is between 600 and 300, depending on how big n is. So, and we'll talk about writing the formulas in a second. But I mean, this is a formula. I mean, this average this is a formula in terms of n. It's going to be closer to 600 if n is bigger. In other words, closer to 25. It's going to be closer to 300 if n is smaller. So, I mean, you give, but I mean, if you have a number for this, then if you have a numerical value for this, you'll be able to find n. Sure, you will. Because I mean, the more days you have at the higher amount, then that means that the later you made your payment, or the earlier you make your payment, the lower the average is going to be. So there you go. I mean, if you realize this, then you don't have to do the math. You can just say, okay, if you have this average daily balance and you can put it at a number, that's going to tell you exactly when you made the payment. Like in other words, if you want to think about this in terms of words, like the earlier you made the payment, the lower the average would be. The later you made the payment, the higher the average would be. Therefore, this specific value pinpoints the payment date. That's how you could think about this. Yeah, it's not supposed to be opaque. There you go. I mean, you can think about statement 2 this way, which is also the way that you can think about the original problem statement too. Like, this kind of situation is, in fact, the same sort of situation as the original problem statement. It's just for 25 days instead of 30. So it's the same sort of deal. I mean, we can talk about the actual algebra here in a sec, but in terms of mentalities that will help you get better at data sufficiency, it's probably more important to be able to think through this without necessarily setting up formulas. So, does everybody see how this works? I mean, the two statements will never contradict each other because that's not how they write these problems. But that's not, in general, thinking about that is not going to really help you much because we're not combining the statements in the first place. So thinking about whether they are consistent with each other is not going to be terribly helpful. But can I draw a picture? I have no idea how I would do that. Sorry. I don't know how I would possibly do that for you, Robert. Sorry. Okay. I mean, but just think about it. I mean, just think about making payments on a credit card account. It probably makes sense to you that if you make an earlier payment, then that means just think about interest or something. Like think about an interest-bearing account, and just think about the fact that you will owe less interest if you pay earlier. I mean, that's basically common sense. That's the same sort of thing here. So, okay. I mean, you have to think about balance themes for that, and then you're kind of not thinking about this the way you should be thinking about it. Okay. I mean, these actually do work out to be the same day. Like if people who are talking about statements being consistent or contradictory or what have you, these do actually work out to the same day of the month. But that's not going to help anybody solve this. If you did want to actually write formulas, which you should also be able to do, I mean, that's not, that should not be the only way that you can solve these things, but that should be a thing that you are also able to do. Let's say that you have n days at $600 and 30 minus n days at $300. Notice that it doesn't really matter whether n is the date of the payment or not. It's most convenient to write it so that n is the number of days at $600. So, and effectively n plus 1 is the day when you made the payment here, which is also fine. So then the total average is the total over the sum. So that's going to be n days times $600 per day plus 30 minus n days times $300 per day over a total of 30 days. Okay, so that. You could simplify this if you wanted to simplify it, I suppose. 600 n minus 300 n. So that's going to be 300 n. And then plus, what's 30 times 300 is 9,000. So 300 n plus 9,000 over 30. Well, that's convenient. So it's actually the average balance is just 10n plus 300. Okay. That works. And then you could write a similar formula for this. I mean, it wouldn't be the same formula, but it would be a lot like this for statement 2. And that's something you could try at home, basically. But the point is you should be able to think through these like this, too. I mean, you should be able to work through these kinds of things without writing formulas for that. Because that's kind of half the point of data sufficiency, is to not have to write formulas all the time. In fact, let me give you a problem here. How about this one? Guys, this isn't really a word problem, but I like this next problem. Haroon, you can't make general rules for how to guess problems. You always have to think about the particulars of the problem at hand. I mean, one thing that is super consistent about this test is that if you think you can make rules for how to guess these things, then you're going to get burned on that. That's like super consistent, promise you. Okay. But I'm putting another problem on the board here. This one, just because people seem to be sort of obsessed with writing formulas here, that's what made me think of the problem that I'm going to put here. Yeah, it's D. Each statement is individually sufficient. D like dog. Yep. This problem is fun. If you feel like you have to write formulas for everything, you're going to have a lot. Stephanie, stop putting D. Okay. All right. Okay. This one's going to be fun. If you feel like you have to write a formula for everything in the world, this one's going to be a lot of fun. All right, it's not a word problem, but it'll be fun if you guys are of the school of thought that you have to write formulas for everything in the world. Okay, you should be answering this one pretty soon. Remember that time management is almost exclusively, if you're stuck, move on, guys. That's basically almost entirely what time management is. Okay. There's still like 3 or 4 you haven't answered yet, but let's talk about it. So, okay, I basically put this problem up here as a gift to those of you who feel like you have to write formulas for everything in the world, because Because you can't write formulas for this problem. It's a pretty cool problem, right? Like, okay, I mean, if statement 2 does not take you like 1 second, there are some serious issues there as far as the way that you are processing data sufficiency problems. Okay, statement 2 is sufficient, guys. And I mean, I really mean it to take you like 1 second. Can anybody explain that one? Because you can just count them, right? I mean, these are 2 hard values. I mean, there's going to be some number of primes. I mean, who knows how many there are? But you know, there's going to be some number of primes between 1 and 3,912, and you can just count them. On your fingers. So it could be a single number. Yeah, you're looking for a value of P, but it's a data sufficiency problem, which means that if you can find, okay, I mean, remember what you need to do is you have to really fully understand what sufficient and not sufficient mean. So, like, sufficient means that there. Make sure you guys know this. What does not sufficient mean here? Yeah, 2 different possibilities would mean not sufficient, right? Like, not sufficient here would mean that there, like, P could have 2 or more different values. Sufficient means P can only have 1 value. I mean, obviously there cannot be 2 or more different answers to this question. I mean, there is clearly only 1 number of primes between 1 and 3,912. I mean, this is an answer that has 1. This is a question that has 1 answer. This is kind of like, Ron, how old are you? I can't have 2 answers. I mean, it's like anything else. So again, if this is not completely, totally obvious, then there are definite holes in your understanding of data sufficiency. And usually what that comes from is people trying to jump into problems that are too hard for them right away. Like, you should do a bunch of data sufficiency problems that are, quote, easy, unquote, before you start jumping into problems where the problem itself is more challenging, because this needs to be totally instinct. So, but yeah, this is definitely a single value. So, I mean, you don't have to find this value because primes don't have patterns or formulas. So the only way that you could actually find this number would be to literally count all of these primes. And that's what's cool about this problem, because no one's going to do that. But ironically, that makes this problem easier in a certain sense, because in a lot of these problems, they are things that you could find, like that weighted average problem, and so you could actually waste a lot of time finding stuff. But here, I think everybody knows that you're not supposed to actually count hundreds and hundreds of primes. So I hope so. So, but this is definitely just 1 number. And then this one, I mean, this one probably takes a little bit more thought, but if you think about this, the fact that this is a prime plus 1 is what makes this also sufficient. Like, if you So people who are typing in the chat now, does this make sense? Because like this should be literally 1 second with no effort at all. I mean, and if it is, it probably means that you were trying to jump into problems that you felt were hard before you really understood this format. So, but it says what? Second says that it should be. It says P is the number of primes between these two things. It means that you don't find the value. That's the point. It's data sufficiency. The point of data sufficiency is just this. I mean, remember these workshops, these Thursday study halls assume that you are familiar with this format on some sort of basic level. I mean, if this is new enough to you that you actually haven't seen this problem format, then we do request that you like familiarize yourself with it on some sort of basic level first. But this is all you need to know for data sufficiency. Is there one value of this, or are there two or more values? So that's the point. That's the entire point. That's why I picked this problem and gave it to you guys. Because you can't find the value unless you actually count all of those primes. Yeah. Statement 1 is a little bit more challenging because you actually have to process the fact that P is prime in order to understand statement 1. Because if P was like some random number here, then statement 1 would actually not be sufficient. You know, because you could increment some random number and still not have another prime in that interval. But the fact that this is a prime, see, if you knock this one up to the next prime value, so to speak, then you would, like, if P is the 100, like basically statement 1 is telling you that P is the 100th prime number. So, I mean, if you think about this, like you've got 1, 2, 3, 4, 5, blah, 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 P plus 1. Okay, and if you literally are going to count these primes, I mean, like, okay, that's a prime, that's a prime, that's a prime, that's a prime. So, like, this is 100 primes. But, see, if because you know that P has to be prime is the deal. Like, if P was the next, if P was the next greater prime, then there would be 101 primes in here. And so that would work with the statement. And if P were any smaller, there would be less than 100 primes. That wouldn't work either. So this is sufficient because there has to be the 100th prime number. Why the P plus 1 is there? Because if No, if you were told that it was any number, then it wouldn't work. Yeah, the prime numbers. Yeah, it's gonna be a lot smaller than 3,911 because they're like the numbers between 1 and 3,912 are certainly not all prime. I mean, it's probably going to be a few hundred, but the only way to find that out, again, the only way to find that out would be to count them. I mean, if you, like P is going to be whatever the 100th prime number is. I mean, you could probably look that up on the internet, but unless you wanted to count them. I mean, if you, like, no, it does matter that it's prime. Like if you had, Mick, if you change the question to what you're asking, I mean, let's make this with smaller numbers so that it's easier to deal with. But if you made what you're asking, then it wouldn't work anymore. Like if you said, what is value of n? And you said, there are, let's say, 4 prime numbers between 1 and n. This would actually be not sufficient. Like if this was just some random integer, because if you do this, then those primes could be 2, 3, 5, and 7. And then here, n could be 8, or 9, or 10, or 11. Like it actually does matter a lot that it's a prime plus 1. So, these problems are, I mean, almost everything about these problems is on purpose. And if you think about, like in general, if you think, oh, I could just take out something like this and it wouldn't matter, then in like 99% of cases, you are going to be very wrong about that. And you should think very carefully about that when you review these problems. Like if there's a feature of these problems that looks conspicuous enough, then it's probably there for a reason, you know, because nobody is going to put something like prime plus 1 in here for no reason. Like that's not going to be random and stupid. So if it's there, then you should be like, why is that there, dude? There's going to be a reason. So you should think carefully about that. Okay, cool. Let's do another one. Let's do the problem. How about this one? All right, let's discuss. We can probably move through this relatively quickly and get to another one because most of you did pretty well on this one. So total revenue is what percent greater? So that is like how much more than, and I mean we want to know, like it's we have revenue per, we have the selling price per sofa, and we also have the number of sofas. So in general, what we should just, this is organize that. to make it a little bit easier on ourselves, right? So we have the price per unit, and then we have the number of sofas, so we can multiply that. And then that's the total. And we can have last year versus this year. And so then you're going to take the percentage increase. And since this is a data sufficiency problem, you would want this to, you'd want to make 2 copies of that chart. 1 copy for statement 1, and 1 copy for statement 2. Remember, you should always do that, because remember, when you do a data sufficiency problem, you're not really doing a problem. I mean, we casually refer to it as a problem, but remember that a data sufficiency problem is not actually a problem. It's actually 2 problems that are independent. And then you may have to combine them, but then it's not a 3rd problem if you combine them, because if you combine them, you're really just importing data from one problem into the other. So, but okay. So statement 1. So this is just percentage. So we're not going to know anything about, I mean, this is not going to be sufficient, right? Because we're not going to be able to do anything here because we don't know anything about money. Statement 2, the selling price per sofa. Yeah, we don't know anything about that. And then here we don't know anything about the number of sofas, so therefore we don't know anything about that. So we don't know anything about quantities. So that gets us to the combination pretty quickly. So let's combine the statements. All right, so 2 statements combined. All right, so remember you just write everything on there so that you don't have to keep referring up to the problem statement. So the price was up 30. Just write that on there, and then this went up by 10%. Okay. And then you want to find, the goal here is to find the percent increase. And we should make another box for that. All right, sure. So let's just test cases for this. I mean, that's just easier to do than trying to write formulas. So, I mean, price per sofa went up by 30. I mean, we could make that like, these would be awfully cheap sofas, but 10 and 40. And then number of sofas up 10%, that could be 100 and 110. So total revenue in that case would be 1,000 and what would that be, 4,400. So that's a total increase of, well, that's a lot, right? It's 4,400 minus 1,000 over 1,000. Times 100%. So that's 30. That's 340%. I mean, I'm already suspecting this is not sufficient because it just I, I don't think they would write a percentage increase problem where the single value was 340%. But you know what I mean? Like it just percent increases are not. If there was a single value for this, I highly doubt that it would be greater than 100%. But you never know. So you could always just, all right. All right, let's hit the price per sofa. I mean, let's test more values. Let's keep the numbers the same. Let's say they went to let's say the prices were like 100. Let's say the prices were 1,000 and 1,030. So then the number of sofas, that would be 100,000, and then I can't do that in my head. 3 and 130, 104 30. So that's definitely a lot less than 340%. So then, no, it's not a C trap at all. Not even sort of. It's a lot less than 340%. So this is not sufficient. So we got two values. So there we go. It's E alpha. There are like 3 entire Thursday study hall sessions about C traps. You should watch those. That's not the point right now, and it wouldn't be conducive to do that at this point. But a C trap is when it is like completely obvious that you can combine statements in a way that is sufficient, which is not true at all here. Like, you know, a C trap is like, what is the area of this triangle? And statement 1 is the base, and statement 2 is the height. Like that's a C trap. Or, you know, like what is the area of this rectangle? And statement 1 is the width, and statement 2 is the length. Things like that. It's not a C trap, guys. No, it's not. It's not a C trap at all. Stop calling it a C trap. You should watch there are at least 3 full Thursday sessions on C traps. Watch them, please. Okay. Let's do. If you had a percentage, if these were all percentages, I do think that would just. I don't know, but if you go to the Thursday archive and just search the page for the word trap, then you'll find it. So just like search the text of the page for the word trap. All right, let's do one more of these. What about this one? Right here. Let's do it. Okay, let's start taking a look at this. If you don't have an answer down, you should pick one. Let's try to fast forward through our discussion here so we can finish close to on time. All right. Total of $500,000. The only costs were labor and materials. So was the profit greater than 150,000? Okay. So that's the question. So the only cost, I mean, you guys know, right, profit, this is actually the only thing you have to know about business / finance for this entire exam is that profit, which they will sometimes call gross profit, but whether or not that adjective is in front of profit is actually irrelevant. It's revenue minus cost. So interest formulas, you do have to know how to do like simple interest, but that's actually just a percentage. So as long as you know how to calculate percentages, you'll be fine. The problems about compound interest that I've seen, all of them, the answer choices have been such that if you just use a little bit of common sense, you can actually solve them that way too. Like if you just realize that compound interest is like almost the same as just a percentage, but it's like a little bit more. You know, like if something gets 8% a year compound interest, it'll wind up being like a little bit more than just straight 8% a year. It's actually good enough. Because like all the wrong answers will be like way the heck off of that. But I haven't even seen, they haven't released any problems that depended on that in years and years anyway. But the ones they have released have always just had common sense as a backdoor. But okay, so profit. So the revenue is 500,000. So is 500,000 minus labor minus materials greater than 150,000? So you can do some algebra here. You can subtract 500,000 from both sides. And then you can multiply both sides by -1, which will turn that into, last then, is labor plus materials less than 350,000? That's the real question. I mean, you do that before you even get out of the gate. So that's the real question. This is a yes or no type of situation. We've talked about yes, no type of situations before in data sufficiency. We've done a few sessions on it. You can check out those archived sessions. I've talked about setting up this kind of device where you basically translate the yes and the no possibilities into actual concrete outcomes. So a yes to this means that the labor plus materials is actually less than 350,000. And a no to this would mean that the labor plus the materials is greater than or equal to 350K. And then remember that if you can make, this is for statement 1, statement 2, and then if you have to combine them, you have to combine them. And just remember that if you can make both of these happen, that's not sufficient. So, as far as this device is concerned, we talked about this in more depth in the sessions that are dedicated to yes/no data sufficiencies, but I would definitely recommend making this device for every yes/no data sufficiency problem. So, definitely making life easier. Okay, so, I mean, because that way you'll see right away. I mean, statement one is not sufficient, right? Because, I mean, the total cost, that doesn't tell you whether it's below or above 350. I mean, this is saying total cost is labor plus materials. I mean, you can do something with this. I mean, total cost is labor and materials. So labor plus materials is 3 times materials. So you can subtract materials from both sides. Labor equals twice the cost of materials. That's great. This is useful for sure, but this doesn't tell us anything about whether these things are greater than or less than 350,000. So not sufficient. I mean, we can definitely get this to be either, so we can check mark both of these possibilities. I mean, this is useful, of course, but doesn't tell us anything about whether total cost is less than or greater than. Okay. And the profit was greater than its cost for labor. Well, that we should write an equation for. So the profit is 500,000 minus labor minus materials. And that's greater than labor. So add labor to both sides. So that looks like let's just add everything to the other side. So 500,000 to labor plus materials. So this, I mean, labor and materials could be 0 here. So this could definitely be less than 250K. Here, 2 labor plus materials is less than 500,000. Can you make labor plus materials greater than 350K? I mean, sure, yeah, you could, right? Like, what if materials are, if materials are, you can rearrange this to labor plus materials is less than 500,000. So if you wanted 2 times labor plus materials to be less than 500,000, but labor plus materials to be greater than 350, if you wanted to make both of these true, then you could do that by making materials cost 400,000 and labor is free. I mean, that's, yeah, an extreme case, but it works. So you can check off the bottom box there. With inequalities, you got to be careful with things like unknowns and counting variables and equations and stuff. It's not always super meaningful when it comes to inequalities. In fact, counting variables and equations is pretty much unreliable across the board here. Like, if there's one in data sufficiency, if there's one thing that really doesn't ever work, it's the whole and equations and variables thing. But Yeah. Anyway, especially on here. So if you want to substitute this, okay, so if you want to combine these things, so let's combine these things. So we can substitute this into here. So labor is 2 times materials, so we can plug that into there. So that gives us 500,000 is greater than greater than 2 times materials plus materials. So 500,000 is greater than 5 times material. So materials cost less than 500,000, or cost less than 100,000. And then labor is twice as expensive as materials. So labor is less than 200,000. And so that's going to be a total of less than 300,000. So that's going to check off the top box, and the bottom box is impossible to check off. So these were not sufficient, and sufficient. This is C like cat. Because the total is less than 300,000. I mean, yeah. I mean, not terribly intellectually satisfying result here, but it is what it is. Okay, neat. Notice that this is all about writing stuff down, and I mean, a lot of people have E here, which honestly, if you have E here, it probably just means you try to do too many steps in your head and didn't write enough stuff down. So that's what people do on these. People are way too invested in trying to do math in their heads on these problems. Don't do it, guys. Don't try to do math in your head. It's not a thing. Don't do it. Okay. We are way over time here, so let's kill it. Thank you. And good afternoon, good evening, good night, good luck, a whole bit. And I will see you next time.